In this last approach to regression using scikit-learn, I want to talk about how to use what is called k-folds cross-validation. And this is, I would say, somewhat similar to the test train split in the sense that we have a train set and we have a test set. But the way that this works is slightly different. And I want to demonstrate how this works. So what ends up happening is we will use, when we use the cross-val function, and this is something that we have already imported earlier in the notebook, which is right here. This is the function that we are importing. We call this an object as well. I'm going to go back down. There are certain things that we're going to be typing inside here. Now, let me just kind of take a few steps back and to show you that in this code cell, I am just instantiating a model. I'm calling this model CV for this variable. And now I'm going to just refer to this whenever it asks me to use an estimator. I refer to this variable. Now I have another variable called CV results, and we're going to have some results that we'll take a look at it in a second. But going back to this function right here, cross-val score, and we take a look at the arguments, we need to indicate an estimator, and that would be what I instantiated, which is model CV, and then followed by the data that we're going to use for X. And I can expand this a little bit, and if there's going to be a target variable, which there will be in our case, we would indicate Y, and then we can indicate other keyword arguments. The one in particular that we can pay attention to is CV, right? We don't have to pay attention to every single one of them, but CV is something that we will interact with. And CV is the number of partitions that you want to, or the number of folds that you want to have. And the way that this is best understood is through this diagram within the scikit-learn library documentation. And here we have an example of a 5-fold cross-validation. And what's going on here in this diagram is that, let's say we have a data set and we have a data frame, and we're going to eventually split it where we have training data and then we have test data. You can see this stuff is color coded. Now, if we want to say CV equals 5, then we're basically going to be splitting our data 5 times. Now, what we have here is an example of different iterations that the algorithm will go through. And if we just follow the first example where it says split 1, that would be the first iteration of a CV equals 5, right? Because we have 5 splits. And when we pay attention to split 1, we have 1, 2, 3, 4, 5 folds. One of the folds is in blue, and then the remaining is in green. So the green is the training data, and then the blue is the test data. That means in the first iteration, what ends up happening, and you can kind of think about it in the sense of everything from fold 1 to fold 5, that's all of the data that you have in your data frame. But what's going to happen in this first iteration is it's going to fold a portion of that data. And that portion of the data is going to be reserved for the test. Then the remaining is going to be for the training. Now, the assumption here is that the data has already been shuffled around, it's random, because if it's not, then you'll generate incorrect results. But we're going to assume that the data is already, our data frame is already in a random order. But now this first iteration, this fold that's reserved for the test data, that represents a certain proportion of the data points in your data frame. So this right here, fold 1, would represent, in this case, 20% is reserved for the test data, and then the remaining would be used for the train data. Okay, that's the first iteration. It'll use the green for training. After it trains, it will use the remaining, which is in blue, as a test, and it will shoot out an accuracy score, an R squared. Then after this first iteration happens, we'll go to the second iteration. And then in the second iteration, again, just think about everything that you see from fold 1 through fold 5 as the entire data frame, just all lined up. But then there's a part in that data frame that is reserved for the test data. And that's that where it says fold blue. That's the 20% of the data that's reserved for the test. The remaining green parts would be used for the train. And then you just keep on going through each iteration. Now, what this is saying is that with this approach, right, this approach that's called k-fold cross-validation, what ends up happening is every single data point that you have in your data frame is going to have an opportunity to be part of the train as well as part of the test. Right? And that's a little bit different from the train test split approach. Not every data point is going to have an opportunity to be in the train set and the test set, whereas this one will, right? So this is an example of a CV equals 5 or a 5-fold cross-validation. And let me go ahead and go back right here and start working on this part of the problem. Now, what I'm going to include here is the estimator. And the estimator is what I'm instantiating, which is this variable right here. Now, I'm going to put that as the first argument, followed by the x and the y. Now, what I'm going to do in this example is I'm just going to do a simple linear regression model where I'll just have one feature and one target. Our feature is going to be the next one up. I'd have to enter in this function, and that's going to be the TV variable. Next is going to be the target, and for the target, I'm going to go ahead and say sales, right? Like that. And then if I want, I can call the CV equals 5. I don't have to, because if I leave it alone and not put CV equals 5, it's automatically going to result to CV equals 5 in the backend according to the documentation. Right here, it's set to none in the backend, meaning that it's going to use a 5-fold cross-validation. If I don't want it to do a 5-fold, I can change it to a 3-fold, for example. I can do that. But 5-fold is the default. But let's go ahead and continue on. Now, I think there is also, let's see, there may not be. There isn't. That's fine. Now, I'm gonna go ahead and do this. Now, I want to print out what's going to happen when I run these 2 lines of code, and I want to just print out that variable called CV results. Now, once I do that, I'm going to go ahead and I'm just going to run it right now. I'm going to execute this cell, and I get a list of values, and these values represent the accuracy scores for each iteration, for each split that occurred. Right? You can see that they're all within the ballpark of like the higher 70s to 80s, right? So it ranges around that much. I can say CV results and just give me the mean of them, right? And it will just give me an overall mean of what we see here. And now when it says on average, the model is blink accurate, we can say is roughly 80% accurate. So this is another approach that could be done in machine learning when you're doing supervised models, particularly regression. You don't want to do train test split, you can do the cross-validation. The cross-validation is I would say, a slightly more reliable approach because of the different iterations that goes through. And then every data point has an opportunity to be in the train and as well as in the test set. And you have these 5 different accuracy scores that you can just aggregate and get the mean and say that my models are accuracies 0.80, right? Now, clearly, the train test split approach also uses randomization, splits it into train test. So that's also reliable. But what's not reliable is the very first approach where you just include all the data in the model and just try to generalize off of that. And that's something that you want to avoid, because we know that if you were to do that approach and it were to introduce new data later on, that you might have something such as an overfit or an underfit type of model, right? So that is the approach when it comes down to using k-fold cross-validation. I can change this value right here and say 3. That means it's going to go through 3 splits, 3 iterations. You can see right here each of the accuracy scores for those 3. And then if we just get the average, we end up getting this value right here, right? 5 seems to be the common one. So I'm just going to go ahead and leave it as that. And just remember that when you have 5, that means you can have 5 different splits or 5 iterations. It's going to produce 5 accuracy scores from the tests for each split, and then you can average it out to get a generalized accuracy score. Now, because we are dealing with a CV equals 5, then that means 1/5, 20% would be reserved for the test set for each split. Okay, so that is all that I want to cover in relation to k-fold cross validation. Thank you for watching.